Welcome to ClickMyProject.com.
Now we are going to discuss about the product and efficient classification of MRI brain images. Now we are going to discuss about the abstract of the process. Brain tumor segmentation and classification are an integral part of both computational intelligence and then the pattern recognition in medical image processing. In this process, efficient algorithm was implemented in segmentation of affected portions such as the brain tumor or else the brain lesions, whatever it is, and then the feature is extracted based on the GLCM algorithm to extract the data from the images. The data will be represented in the form of pattern, textures or color, whatever it is. Here the GLCM is used, hence the features will be in the form of textures. In segmentation step, it is based on the fuzzy C-means clustering algorithm, that is the FCM is proposed for the clustering to segment the region of interest. The region of interest is based on the affected portions. Then this process involved here in medical field to detect the brain tumor, and then the feature classification method is proposed to classify the tumor or then the non-tumor with the help of the K-N classifications, and then it will detect the severity of the input image. Hence figure out all the steps. After that the performance will be evaluated based on the performance parameters like accuracy, sensitivity and specificity to detect whether the process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall flow structure of the process. The middle column represents the modules present in the process. At first, the first stage of the process is the input image. After getting the input image from the dataset, we just move on to the pre-processing. In this pre-processing, we have two kinds of pre-processing. One is image resize, then the another one is the grayscale conversion. In this image resize, the image will be resized into an aspect ratios to maintain the size of the image. After that, the image is converted into a grayscale format. If the input is in the form of RGB, means it will be converted into a grayscale form. After that, the third step of the process is the image segmentation. Hence the GLCM is applied to extract the features. Before that, the segmentation will be carried out by using the clustering methodology. Hence the fuzzy C-means will extract the exact region of interest, that is the tumor region. After extracting the tumor region from the image, the GLCM is applied to extract the corresponding features from the image. GLCM is abbreviated as a gray level co-occurrence matrix. After extracting the GLCM features, the textures and patterns will be extracted from the image. That texture and patterns will be the test feature. After extracting the test feature from the image, we just move on to the next step of the process, that is the classification. In this classification steps, it will detect whether the input is a tumor image or else the non-tumor image with the help of the classifier named as the KNN, that is the K nearest neighbor. The input of the classification will be the three things. First one is the test feature, then the second one is the train feature, then the third one is the labels. Based on those three categories, we just classifying the input as normal or else the tumor one. After the overall completion of the process, the final stage of the process is the performance estimation. In this performance estimation, we have three kinds of performance named as accuracy, sensitivity and specificity. By using these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B and change the current directory. If you want to execute the process, just right click in the main_GUI.m and select the option run. Now the user interface was open. In that user interface, you can see the several push buttons in the right side for the controlling axis and then the several axes in the left side for the display purpose. First of all, click the button input MRI. After clicking the button, the dataset will be appear. You just open the dataset and then select any one image from the dataset. After the selection of the image from the dataset, the corresponding image is shown in the axis 1 with the title input image. After the selection of the input, we just move on to the next process, that is the pre-processing. In this pre-processing, we have two kinds of pre-processing technique. First one is the image resize, then the second one is the image noise filtering. This is the result for the image resize, then this is the results for the image noise filtering. After applying the pre-processing, we just move on to the third stage of the process, that is the segmentation. In this segmentation process, we had applied the fuzzy sequence clustering, hence the clustered result is shown here. This is the cluster number 1, 2, 3 and 4. Finally, we got an exact result in the cluster 2. Now I just click the 2 to select the index 2. After the selection of the corresponding index, that corresponding index will be extracted, then the corresponding segmentation result will be shown like this. After the segmentation completion, we just move on to the feature extraction. In this feature extraction, once the button is clicked, the features will be extracted from the image. Those feature values is tabulated here. After extracting the feature values, we just move on to the classification part. In this classification part, if it is a tumor means the message box will be pop up identified as abnormal. If it is a non-tumor means the message box will be pop up as identified as normal image. After done the classification, we just move on to the performance estimation. Once you click the button performance estimations, the performance parameters like accuracy, sensitivity and specificity will be displayed here. Both will be tabulated as well as it will be represented in the graph format.